We'll proceed in pseudo calculus problems. Pseudo calculus problems. Okay, we have started a discussion on pseudo calculus problems. And in that problem, list of problems, I have a problem that I have to find area of a circle. Okay, so idea is that I have to find area of a circle. What is the area of this circle? That is under question mark. We have found that calculating the area of a circle is nothing but calculating the area of a basic item, that is a rectangle. What is the area of a rectangle? Then area of a rectangle is height by width. Okay, height is y and width is x. Y into x is the area. Okay, in circle, this height y is dependent upon x. This y, that is height. Means if I take circle, y means height. Okay, and x means width. So if I multiply height or length into width, we get the area. But height y into x, but y is dependent upon x. It is function over x. In that sense, y into x would become y dx. Y dx. Okay, then someone can proceed and he can find the area of a circle. Area of a circle, area of a 2D can be found by calculating the cross product of this vector and this vector. This vector A vector, this vector B vector. If I do cross product of these two vectors, consider this is origin and this point is x2 comma y2. Then this vector is x2i plus y2j. If this is origin and this point is x1 y1, in that sense this vector is x1i plus y1j. If I do cross product of A vector and B vector, cross product of A vector and B vector, then certainly we will get an area vector. Calculating the magnitude of the area vector will give the surface area. But problem here is, anyway, what is this vector? This vector is x1i plus y1j. This is a straight line vector. This is a straight line vector. I mean a vector that represents a straight line. But here we need a vector that represents a curved line. Okay, anyway, the vector A and vector B, if I do cross product, I get the area. In that way, vector A is x1i plus y1j. I am removing 1. And vector 2 is x1, vector B is x1 xi. Vector A is xi plus yj. Vector B is xi plus yj. These xi plus yj, they represent a straight line. If I want vector representation of a curved line, then in that way we need a vector representation for a curved line. To get the vector representation of a curved line, where if x is independent, then y by x is variable. If y is independent, then x by y is variable. In the sense, we re-represent our vector as xi plus yj into I plus y by xj, bracket close into x. Cross product with xyyi plus j, bracket close into y. Now if if I resettle it down, then division becomes differentiation and multiplication becomes integration. Because multiplication is nothing more than integration is nothing more than multiplication only. It uses graph to calculate the multiplication. In that form, now it becomes like I plus dy by dxj, bracket close into dx. Y by x become dy by dx, and I plus dy by dxj, that is function over x into x, become into dx. Cross product with dx by dy plus dx by dyj plus dx by dyi plus j, bracket close into dy. If I do these two cross product, then it becomes I plus dy by dx j cross product dx by dy I plus j dx dy. This is the area vector. But problem here is there are two independent components comes into the picture, dx dy. But here if I calculate the area of this, then y is dependent upon x. Only one independent component is there, that is x, not y. If I have dx dy, means it represents 3D. It represents 3D. If it represents 3D, where we have z, in that sense, dy by dx, x and y will be considered as independent to each other, xy plane. Z will be considered as dependent on xy plane. This is x-axis, this is y-axis, this is z. Z is dependent upon xy plane. In that sense, x and y are independent to each other and z is dependent upon xy plane. Indirectly, z is dependent upon x and y. Okay, anyway, to calculate the area of this circle in 3D, we took deliberately height as 1 and then calculated the volume. If I am going to calculate a volume of a cylinder, because if this is a circle and take a height 1 all around, it becomes a cylinder. If it becomes a cylinder, then the volume of cylinder will be area of this circle only, because height is 1. Okay, we use this mathematics trick and or loophole in mathematics, whatever it is. Then we saw if that is the case, then dy by dx will be 0, because y and x are independent to each other, knowingly, unknowingly. Then it will become I cross j, dx by dy also will be 0. I cross j means k unit vector dx dy will be area of this will be surface area vector of this surface. In that sense, if I do dot product with the z, it will give the volume, because we are in phase of calculating the volume. Then it will be k, I'm sorry, z k unit vector or 1 k unit vector. K unit vector dot k unit vector dx dy will give the volume. More or less, dx dy will give the volume. Integration of this volume over xy plane, that is a circle. So integration will be over a circle, that is the circle. Dx dy will give the volume with height 1. Okay, the circle is x is minus a to a. This is x axis, this is y axis. Means actually it is like this. This is xy plane and this is z. I'm just rotating it. This is x axis, this is y axis. X is, this is center of the circle, radius is a. X is from minus a to a, and y is minus a square root of a square minus x square to square root of a square minus x square, because y is at the end it will come from here or there only. And now if I integrate, we get pi a square is the area of circle. Is it the end of this story? That area of the circle is this much one? Okay, now we will proceed more. Okay, consider I have a cylinder. I really have a cylinder, and cylinder height is 1 again. Cylinder height is 1, but we are trying to calculate the surface area of the cylinder. Okay, so I have a cylinder, some mischievous cylinder. Okay, so I have this cylinder whose height is 1, and I am trying to calculate. Consider this is a cylinder. I am trying to calculate surface area of the base, and this is the height of the cylinder, that is 1. Okay, if height of cylinder is 1 in 3D, can we calculate surface area of this? That will be same as this. Okay, I have bigger cylinder also. This is bigger cylinder. This is bigger cylinder. Okay, this is bigger cylinder, and then I am trying to calculate surface area. Now I have two circle here. If this is a cylinder, then I have two circle here. What your circle are? This is one circle down base side, and this is top side one circle. Since this is a cylinder, since this is a cylinder and this is base circle and this is the top circle and this height is 1, if that is the case, then I have to find the area of this surface, which is same as area of this top surface. Now, in that case, can we find the area of this top surface and I'll estimate it is same as, then this area is same as this area. If I have a cylinder, hope it is very heavy, okay, more than 2 kilogram, more than 2, it would be 3 kilogram. Okay, if this is a cylinder and I'm trying to find the base area of circle, that is base circle, then I'll, this height is 1 and this top area I will try to find, and then I'll estimate it would, that this top area is same as base area. So I found the base area of the circle. What is the top area of the circle? What is the top area of this circle? Okay, that is under question mark. Now what I'll do is I'm going to cut this. This is x axis and this is y axis and this is z axis. This is xy plane, this is z. Now I'm going to cut this. One I'll make a cut in xz plane and one I'll make a cut in yz plane. Consider I take any point P on this top surface. Top surface is a circle of a cylinder. I take any point P on the top surface. At that point P, I make a cut in xz plane, and at that point P, I make a cut in yz plane. Now, what is the scenario? Scenario is that consider that point P is like this. On the top, I have taken, on the top circle, I have taken a point P. If I cut in xz plane, then there will be a line like this, and this is the point P. This is the point P, and there will be a line like this. If I cut in yz plane, this is point P, and there will be a line like this. So there is a point P. Now consider there is a point P here, and with the point P, one line is passing like this. At point P, another line is passing like this. If I take cross product of this vector and this vector, I'll get at P, I'll get the surface area vector. Makes sense? Like if I take any point P here and I take a line like vector like this, and at point P here I take a vector like this. If I calculate the cross product of these two vectors, I'll get at P, I'll get the surface area vector that is the perpendicular to this direction. Surface area vector at any point P, if I take two lines at point P, if I do cross product of these two lines, I'll get the surface area vector. If these two lines intersect at 90 degree, it will give surface area vector of a rectangle, otherwise parallelogram. In that way, if I cut this, if I cut this top circle, if I take any point out, consider this is the point. Okay, this is the point. At this point, I make a cut like this in xz plane, and at this point, I make a cut like this in yz plane. If I do so, if I make a cut like this and I make a cut like this, then at point P, I have a line like this and line like this. Okay, now we will do the cross product of these two, and then we will get the surface area vector at point P on the top circular area. Okay, let's proceed. Okay, so what is the line vector in xz plane? If I talk about xz plane a line, then y is constant in xz plane. If I talk about the xz plane of a line, yz plane of a line, then x is constant. Okay, in that fashion, in xz plane, if I'm talking taking the line in xz plane, I'm taking the line. What would be the equation of the line? If point P is x comma y comma z, then vector for that point is xi plus yj plus zk. If I am trying to represent this line, if I am trying to represent this line as a line in a curve vector manner, I have to take out x or x as in xz plane. X is independent, z is dependent. In yz plane, y is independent and z is dependent. In xz plane, I have a line like this. If I have a line like this, I have a p as position vector. Now, if I have a p as position vector, I'm trying to find the vector representation of this line. Okay, now to find, we have talked tons of time how to get vector representation of a line. To get vector representation of a line, first I'll consider the one end is origin and I'm trying to get vector representation of a line, and this point is x comma y comma z. Then vector will be xi plus yj plus zk. But this will be a representation of a line that is straight. If I want representation of a line that is not a straight line, then I have to represent this vector in form of y by x, z by x. Then only it will represent a curved line. In that sense, I'll take out x and it becomes I plus y by x, j plus z by x, k, bracket close into x. Okay, now here in xz plane y is constant, y is not varying. Means y by x will be 0. Y is not, if y is not varying, then how y by x will be 0? Anyway, we will modify and will make division and differentiation and multiplication and integral calculus. Now it will become I plus dy by dxj plus dz by dxk, bracket close into dx. Now dy by dx will be 0 because there is no variation in the y seen when there is a one unit change along x. Now dy by dx will be 0. So in that way, I plus dz by dxk, bracket close into dx, is the line equation of the line that I make a cut in xz plane on the top circle. It makes a line. Similarly, in yz plane, it is again xi plus yj plus zk. I'll take out y because y is independent component. In that sense, it becomes x by yi plus j plus z by yk, bracket close into y. Now x is constant. Now if I move ahead and modify the division with differentiation and then multiplication with integration, then dx by dyi plus j plus dz by dyk, bracket close into dy. This is what it will become. Dx by dy is 0 because x is not changing in yz plane. In that sense, it becomes j plus dz by dyk, bracket close into dy. Make sense? Okay, if that is the case, then it would become cross product of I plus dz by dxk, cross product j plus dz by dyk, dx dy. This cross product will become minus dz by dxi minus dz by dyj plus k. Okay, and then bracket close into dx dy. Now anyone would say, but you said that z is 1. Z is 1. If I take the top circle, z is not changing anywhere. It is 1. It is constant. Like if I take this, cylinder, okay, if I take this, if I take this if I take this cylinder, if I take this cylinder, then top circle and bottom circle, Z is constant, Z is not varying. On top circle, every point of the top circle, Z is constant. If that is the case, then dz by dx will be 0 because Z is not varying. I have not taken this surface. If I take this surface, then everywhere Z will be different. Z will vary from here to here. I have taken only one surface, that is top surface. Everywhere on the top surface, Z is constant. Anyway, I have taken 1 as the Z. Then minus dz by dxi minus dz by dyj plus k, bracket close into dx dy. If that is the case, then dz by dx is 0. It is not changing. Dz by dy is 0. It is not changing. Only k will remain. At the end, it comes as k dx dy only. If that is the case, then I'm sorry, it came as k dx dy. This is called area vector. If I'm trying to calculate the area, I have to find the magnitude of this area vector, and that will k will go away. Dx dy integration over a circular region, and that is the circular region. On the circular region, this is the circular region. If this is xy plane, then this is parallel to the xy plane. For circular region, x is again minus a to a, and y is minus a square root of a square to a square root of a square minus x square. X is from minus a to a, and y is minus a square root of a square minus x square to a square root of a square minus x square. Because for a circle, x square plus y square equal to a square. Now we have integration dx dy. Integration limit is on xy plane, and that is x is minus a to a, and y is minus square root of a square minus x square to square root of a square minus x square. Okay, someone would say dx dy, you took x as independent and y is dependent in the limit region. Can I take reverse? You can take reverse. Y is minus a to a, and x is minus a square root of a square minus y square to a square root of a square minus y square. Everything will work out. Now, if I go with y dy integration first, it will become y. Y means minus a square root of a square minus x square to square root of a square minus x square. 2 square root of a square minus x square dx. 2 I can keep outside. X equal to a cos theta. It becomes a sin theta, a minus sin theta d theta. X equal to a cos theta dx equal to a minus sin theta d theta. Okay, a I can keep outside. It becomes minus a square, and here sine square theta d theta. It becomes theta by 2 minus sine 2 theta by 4. Now, if I see the x integration minus a to a, minus a to a, x equal to a cos theta, theta equal to cos inverse x by a. When x is minus a, cos inverse minus 1. Okay, when x is a, then cos inverse a means integration is pi to 0. Theta by 2 minus sine 2 theta by 4. Okay, when pi to 0, 0 means all gone, pi means minus first, minus minus outside. Cancel it is a 2a square, pi by 2 sine 2 theta by 4. Pi if I k sine will go away, it will become pi by 2. 2 to gone, it becomes pi a square. That is the area of a circle. Mind blowing, amazing. I believe people would not have dreamt about it that someone would calculate area of circle in this fashion also. Okay, what can be the other fashion of calculating the area of the circle? If someone watches it closely, what we did here? Okay, when we said that area of circle is A cross B. If I cut in xz plane, I cut in yz plane. In xz plane, the curve line equation is I plus dy by dxj plus dz by dxk bracket close into dx. If I cut in yz plane, then it is dx by dyi plus j plus dz by dyk bracket close into dy. If someone is watching it carefully, then first one, that is I plus dy by dxj plus dz by dxk, it looks like this is dp by dx. If p is position vector, that is xi plus yj plus zk, dp by dx is exactly I plus dy by dxj plus dz by dxk. Exactly same thing. Okay, another is dx by dy I plus j plus dz by dyk. It is exactly as dp by dy. Means the area vector is nothing but dp by dx cross dp by dy dx dy. This is called area vector. If I have a position vector, if I have a position vector in 3D, in 3 dimension, then dp by dx, p is any point on 3 dimension. If this is a 3 dimension, and this is xy plane on which this is kept. If P is any point on this 3D, then dp by dx cross dp by dy bracket close dx dy, this will result in a vector form. That is the nothing but the position vector, the surface area. If this is point P I have taken, then this is the surface area vector at this point. If point P I have taken here, then this is the surface area vector at this point. Okay, this is one concept. Okay, what can be other concept? Now, if I watch it more closely, dp by dx cross dp by dy into dx dy. dx dy is also called dxy plane, dxy plane. And dp by dx cross dp by dy, more or less it is called dp by dxy plane. Means we are trying to say dp by dxy plane into dxy plane is the surface area, or dxy plane cut down, d of p is the surface area. Means d of p is the surface area. Means if I take any position vector on the surface, if I take any position vector on the surface, then position vector, if consider consider the, okay, I have taken a cylinder. Consider the cylinder is kept on the xy plane. So here this is origin 0 comma 0 comma 0, and this is the p point I have taken. From 0 comma 0 comma 0, if I draw a line, it will pass this p, and that is the position vector. Okay, position vector will pass out from the surface. Okay, if I differentiate this position vector represent the surface area vector. If I differentiate this position vector, I'll give the another vector that will be along the surface, that is tangential to the surface. This is inherent nature of the vector. We have made this proof in some of the video. I believe someone can watch previous 3 weeks video. Somewhere we have done proof that if I have a position vector, then differentiation of the position vector, derivative of position vector, will result into another vector that will be tangential at the position vector. Consider this is a line and this is origin. If this is the origin and this is point P, in that sense this is the position vector. This is the position vector from origin passing the point P. If I calculate derivative of this position vector, it will result into another vector that will be exactly tangential at point P on the line. If this is the position vector, if I calculate derivative of it, it will be exactly tangential at the line. So derivative of position vector is along the line. Similarly, if I take a point, if I take a point Similarly, if I take a point on this here, and from center, if I draw a position vector, if I take the derivative of position vector, it will be along the surface. Okay, position vector, derivative of position is along the surface, then surface vector will be exactly perpendicular direction of the vector. I'm not talking about the magnitude. Direction of the vector will be exactly perpendicular to the surface, whereas direction of the vector in a line in a line, it will be tangent along the line. D of P will be along the line. Okay, but D of P represent a surface area. It will be perpendicular to the surface, but surface, it will talk about the surface area. So if I have a position vector P, D of P, small d, capital P on top of it, arrow mark, D of P, derivative of position vector is the surface area vector. Then I can divide anything by same thing and multiply by the same thing. 5 equal to 5 into x by x. Same thing. So d of p is the area vector. If p is the position vector, position vector representing an area. Position vector can represent a line also. A point on the line, point on the surface area, point on the volume, bigger than that. These are high concepts that will be used in artificial intelligence, because there also multivariable is there, multivariate case is there. Now, if P is the position vector, where P is a point on surface, then D of P is the area vector. d of p is same as d of p by dxy plane into dxy plane. And that is dp by dxy is nothing but dp by dx cross dp by dy. This is what we saw. And then dxy plane. D of p is same as d of p by d of theta r, because I can divide by anything, multiply by the same thing, it will become same thing. D of position vector is nothing but d of p by d of theta r into d of theta r, same thing. If that is the case, then what is dp by d theta r? If I calculate this and multiply by d theta r, will it give the area? This will give an array. This will give a vector. D of position vector is an array, is a vector. D of position vector is another vector. D of position vector by d theta r will be another vector. D theta dr, this is just multiplying. This will resolve into one area vector. If I calculate magnitude of this area vector, will it give the area of the surface of the circle? If I take this theta r and position vector on a circle, okay, that we will see. Okay, please, amazing discussion, right? How to find different way. I have a problem that I want to calculate surface area of a circle, and two way. This is the three ways we have seen. This is the fourth way. We will see, I believe, one more way. Calculate. There can be innumerous way. First, we tried with the height into width. Then we tried with the height vector and width vector. Then we tried with the 3D shape where we took the surface area of a top of a cylinder, and then went with the xz plane and yz plane. Now we are going with the theta r, that is polar coordinate system. Please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number.